Right, so this is section 7.7. We're not really doing a lot of the graphing, but rather I want you to take the real data and we're going to be writing equations based on real data. So if you look at this situation, this is a situation between the years between 1991 and 1999 and the sales of SUV cars. Notice the time. Generally, time goes on the x-axis and cost would be on the y-axis. But one of the things you have to say, does time depend on sales, or does the sales depend on the amount of time? And in this case, our sales is the depender. That is your y. So this has to go from almost 1 million to 4 million. And our time has to go from 1991, our x, up to the year at least 2000. We kind of want to go a little bit before and a little bit after. So as I place this data, we see that this real data creates a linear trend. And when it creates a linear trend, we can draw what's called a line of best fit. That's where we take our ruler, like it's a piece of metal, and these are a bunch of magnetic points, and we try and place it as close as we can in the middle. And then we take, so one more time, when we're doing a line of best fit, we plot the data, we plot the points, then we draw our line of best fit, and then we grab 2 points off that line, preferably pretty far apart. They can be one of the real data points, or they could be just a point on that line. Okay? And then, what do we have the ability to do when we have 2 points, Carter?
You can just slope-intercept.
Close. What do we have the ability to find when we have 2 points? Go.
You can find the slope.
We can find the slope. First, we're going to find the slope, and we're using our slope formula. I'm noticing that a lot of people are getting this wrong because they don't know what y1, x1 is. I'm going to remind you that in an ordered pair, it's always x comma y. So the first one we're going to call x1. The second one is y1. x2, y2. Okay? Now I have the ability to do, I'm basically doing this. 3 minus 1 over 1999, sorry, minus 1.1, 1999 minus 1992. And when I simplify it, I get 3.1 minus, 3 minus, I get 1.9 over 99 over 7. Now, we never leave a decimal in the fraction or a fraction in a fraction, so we have to simplify that. 1 and 9/10 divided by 7, and we get about 271 thousandths. I'm going to cut that off because it's 1/4. 271 thousandths recording. Okay? Now, what do I do with the m? What am I doing with that? David?
You put in a slope-intercept.
We can use slope-intercept, or we can use point slope. I personally like point slope, so I'm going to use 0 and 271. Now, I really should be using about. And I'm going to use this point. 1999, comma 3. And so I'm using my y minus y1 equals m times x minus x1. I also had somebody come show me homework today. You need to have this written down. You need your ordered pairs written down. Otherwise, we can't fix your homework if you can't even see the problem. Okay? The problem should always be written down, those points. Now, I'm substituting in I've got y minus the y1 is 3. So I've got the y1 is 3, the m is 0 and 271 thousandths. I really should switch this to about. And my x1 is what? 1999. So I'm doing y minus 3 is about equal to 271 hundredths x minus, now I'm multiplying 0.271 times 1999 is 541 point about 7. 541 point about 7, right? I'm estimating because it says 729. So I cut it off there. I'm adding 4. I'm adding 4. Oh, I'm sorry. I'm adding 3. Thank you. I'm adding 3. I'm adding 3. So y is about equal to 0 and 271 thousandths x. Now is 538.7, so I'm going to say minus 539. I'm estimating. Because it's 538.7, I'm rounding to the nearest hundredth. I mean, to the nearest.
That's why you have to just go to the equal sign?
Yes, because I've done some rounding here, and because I'm using real data. So here's our equation. Now here I did point slope. Do you have to do point slope? No, it's your choice. Whatever you're more comfortable with. Can I erase this? All right, so here's what it looked like if I had used point slope. If I were to have used slope intercept, I always end in slope intercept. But let's say I chose the other method. Okay? And now I'm going to choose, I guess my PowerPoint chooses this point. And I substitute 1 1/10 in for the y, and 1992 in for the b. And when I multiply that out, and then we solve for the b, subtract 540, and we end up with 530 is negative 539, about.
They round it.
Okay? But I still have to write this equation. I personally like point slope better. But I don't care which method you use here. Okay? So now, stop. Put your hand down. So now we're taking the equation, and what they say by the actual, what they're meaning is that when we did it in the calculator, it's far more accurate because they're including more decimals. It's much closer, but it's still estimated because it's real data. So now that I have that, notice before my data set, well, you can see it right here. It only went to the year 1999. But what we can use that equation for is to predict in 2000, 2001, 2002. Because if this is a linear trend, we can expect it to keep growing in this position, in this way. Do you understand? Yeah. So now we're using that equation, and they're giving us another part. Not only do you write it, but now they want to know, okay, now that you have the equation, predict the sales for the year 2004. Notice our graph only goes up to 2000. So years go in for the X or the Y? X. This is on the X-axis. That's how we know. So I substitute 2004 in for my X. And when I distribute, I end up with about 4. Now remember, if my answer is 4, we've already said this is in millions. So do you understand? So in the year 2004, 1, 2, 3, 4, it should be up to about here. Is that part of the trend line?
Yes.
Yeah. So that is how we use our line of best fit. We write the equation, and then we use some real data outside of our sample to predict future trends. Okay, questions? All right, now we're going to go to the homework. The good thing is you get to start your homework. You're starting it right now with me. So, let's look at number 1. Now, 1 through there's no graphing. If you don't want to graph right now, that's fine because we're going to get to the graph. If you just want to write the equations, that's fine. But every time we are writing the equation, and then we're going to use the equation to predict. Ronnie, are you with me? Outside of the data set. So, Rami, why don't you read?
Question 1.
Start with the directions.
Okay. Solve. Assume a linear relationship fits each set of data.
Okay, look at A. Read what it says for A.
A long distance.
No, find. See where it says A?
Oh, find the linear equation for these data points.
Okay, can you get your head in the game? Just listen. Find the linear equation. So step 1, we have to write the equation. Now read the problem, number 1.
A long distance telephone company advertised the following rates: 5 minutes M for just 85 cents P, and 10 minutes for just $1.10. Use the order pairs M and P.
Okay, so what does M represent? No, normally it does, but in this story, it's our X, but what is it in the story? It stands for minutes. How did you know that the M was for X?
Because it's first.
Because it's written first in this ordered pair right here. It's in the X position. And what does the P represent?
Y.
That is my Y, and it stands for what?
Money.
My money price. Right? So you've got your little XY position here. They're saying minutes is for X, P is for price or Y. Now the first part it says is find a linear equation for these data points. What's the first data point?
Oh, 5.
5, comma, not 85, but 0 and 85 hundredths because it's 85 cents. What's the second data point? 10, comma, 110. This is money, so I'm using that last 0. I don't normally have to. So now that I have 2 points, what do I have the ability to find, Cameron?
The slope.
The slope. So I'm going to use my slope formula. M equals y2 minus y1. Are you with me? TJ, are you with me? Over x2 minus x1. And then I'm doing 110, right?
Yeah.
x1, y1, x2, y2. I'm doing 110 minus 85 cents over 10 minus 5. And then we end up with 0 and 25 hundredths, or 25 cents, over 5. And when I divide 25 cents by 5 parts, I get 5 cents. So my M is really, and I really shouldn't be using equals. Why?
Oh,
About.
It's real data, so I should be using the about. Okay, so I now have my slope. M is about equal to 0 and 5 hundredths. And then I get to choose a point. What point? 10, 110. I like that because it's easy to multiply. Sorry, I just sneezed. Okay, so now I'm gonna, what would I do now? How do I write Roman?
Y minus y1 equals m times the quantity of x minus x1.
Good. And so I'm doing y minus 110, right? Equals, I should put these in a different color. Equals, yeah, I will. I'll switch it. Equals, what's the m? X minus, and I'm substituting in 10. And like Cameron said, well, the first one should be equal because there's no real data, but this one should have been squiggly, like, so it's about sign. And now I can, y minus $1.10 is about equal to 0.05 or 5/100 x minus what? 0.5. Multiplying by a power of 10, I move it over. Now is 0.5 5 cents or 50 cents? Right, it's 50 cents. So now I'm adding $1.10. I'm adding $1.10. And I get y is about equal. Now be careful. Off on the side, take your 110. It's positive. Your 50 cents. Oh. Your 50 cents. We're subtracting, right? And that is what? It's not 160, it's 60 cents. It's 0 and 60. So I get 0 and 5/100 x plus, takes the positive, 0 and 6/10 or 60/100. Now, hold on. What?
Isn't 0.5 times 0.5 0.25? Not 0.05? Isn't it just 0.5?
Hold on.
You said 0.
All right, so now, what I just said to everybody, I'm going back to recording, is when you're adding and subtracting this negative 0 and 5/10 plus 110, that's like minus 50 cents, positive 110. Rewrite it so it's right side up right over here so you don't do the subtraction wrong, especially if you don't have a calculator. All right, so I'm done with only the first part, A. It says, find a linear equation. There it is. Oh, wait, I'm not done because this doesn't reflect the story. The story talked about an M and a P. Where does M go?
X.
M is your X. And P is your Y.
So it's P.
P is about, the price is about equal to 5 cents per minute plus 60 cents. Does that make sense? But I'm done with part A. Now, to find part B, it says use the linear equation to find the cost of a 20-minute phone call. Okay, so I'm using the linear equation. P is about equal to 0.05 m plus 0.6 or 6/10. And now I'm substituting in what and for where? Let's go with Louis. I mean, Julio. For the M, sorry. The price for approximately 5 cents for a 20-minute phone call plus the 60 cents. Now, 20 nickels makes how much?
$1.
Right, makes $1 plus the 60 cents. And so the price is about equal to 160. It's a dollar amount. So basically what we're saying is 20 minutes will cost $1.60 will be the price. Okay? But these are the two parts, right here and right here. A, they want the equation. B, they want the cost for 20 minutes. Okay? That's number 1 for your homework.
Wait, do we have to write the bottom 20 minutes down?
Doesn't matter now. Yes.
I have two questions. So, first of all, why is it about? Because didn't they give
Because as soon as you use we're using real data. It's real data. And this is a sample in the world. It doesn't express every single data point. Okay?
And also, you said that the 0.45 divided by 5 is 0.05?
Try doing the long division. Don't ask me how to do that. Do the long division. Yeah.
So if we were going to graph,
We're not graphing right now. Okay? Don't worry about it because we're going to have a whole day on just graphing. If you can get these to an equation and utilize them, I'll be happy. Okay? Questions? Can I erase? Okay. Let's pause it. The next thing I'm going to have you guys do is you're going to work on number 2, and you're going to check it with your table partner. Okay? So you're going to work this with... Okay, we're going to work on number 2. Find the 2 data points, find the slope, write the equation, and then use the new piece of data. Does that make sense? Pause the recording and try this one on your own.
can we do this with our partner?
Right, so now this time I'm going to use the y equals mx plus b method. Although I don't like it, I will be using it. Okay, what are my ordered pairs first? Shh. Go, Kate. 0, 32 and 10, 50. And remember, it's C, F. So the first thing I'm doing is finding my slope, y2 minus y1 over x2 minus x1. I'm substituting in 50 minus 32 over 10 minus 0. So it becomes 18 over 10. I can reduce it to 9 over 5, or I can divide it out. 9 divided by 5 is 1 8/10. So M is about equal to. Okay, so now I'm using M equals 1.8, and I'm going to use the point 0, 32. Y equals mx plus b. I'm doing 32 equals 1.8 times 0 plus b. 32 equals my b. So what is the equation? I'm doing y equals 1 8/10 x plus 32. But we were given a C and an F. So what is the C? Right? What is the C? What position is it in?
It's X.
Okay, so C goes here. And where does the F go?
Y.
For the Y. And so here's the equation. Okay? I want to see it with the proper variables. Then we had to use it, and what did they say? What did they say? F equals 1 8/10 C plus 32. That we had to substitute 30 degrees Celsius. So I'm doing F equals 1 8/10 times 30 plus 32. If I didn't have a calculator, I'd keep it in fraction form. Do you understand why? Since if I don't have a calculator, it's easier to do in fraction form. Watch. 9/5. Right? That becomes a 6. It's 54 plus 32. So the Fahrenheit is equal to 86 degrees. Do you see? Now, you could have written it like that, or F equals 5/9 C plus 32. Either of these are correct. Do you understand? Yeah.
Why did you do like
The amounts?
the about sign? Like
Oh, I should have.
Yeah.
I'm just trying to go fast. So there we go. Yes, quick, go.
If we didn't have the right variables on the test, would it be wrong?
Yeah, I'll mark it half off. Okay, the first one I didn't need could have just done my equal signs. Okay, so that's 1 through 10. I don't want you to get worried if you get a table. Now, I told you there's going to be a lot of graphing to come. So when you get something like this, we can still just pull 2 points that are far away. Here's 1 point. This is number 8. Here's another. What would my 2 points be? 2, 4, and 20, 31. They're talking about miles for a cost of a taxi. Yeah.
How would you know which one is the X and which one's the Y?
Well, they put it for you.
Oh.
Well, what's dependent? Is the cost dependent on how far you go, or is how far you go
The cost is depending.
Right. So cost, if whatever's the depender becomes your Y, because eventually they're not going to give you this. They're not going to give you this. You're going to have to figure out what is the depender, and that becomes your Y. Yes, Rami.
On to question 3. So I got 2,000 meters, or yeah, 2,000 meters, 500 meters from one point because it's H, T. But how do you get the second one?
Okay, I'm going to stop the recording, and we're done with this.